In this lesson, we are going to talk about end behavior of polynomials as well as multiplicity. So we're going to start first with end behavior. Just grabbing some extra colors. So the first thing we need to look at is these two graphs here. We're going to look at how they are alike and how they are different. So one thing I notice right away, how they are alike, they both have a -5, which shows up as the y-intercept. So they both have that -5 y-intercept. Another thing I notice is both of these are linear functions. Something I notice that's different is this one over here on the left is an increasing function. It has a positive slope here. And this one is a decreasing function and has a negative slope. So those are some things that I notice here. The next one, we have two quadratics. The first one is x squared. The second one is -x squared. So some things I notice, they both have the same vertex, which is also the x and y intercept in both of these. There's no stretch or compression. There's no shift to the left or to the right. So these are all things that they have in common. The difference is one is opening up and the other is opening down. And as you may have guessed, the next one is 3 factors that are being multiplied together. So if we think about what the leading coefficient would be here, I have x times x times x. Same thing over here. This leading coefficient would be x cubed. This leading coefficient would be -x cubed. So one way that they are different is one has a positive leading coefficient, the other has a negative leading coefficient. Some similarities though, they are both cubic functions. They both have 3 factors, 3 x-intercepts, and they happen to be the same x-intercepts. This would be x equals -1, x equals 2, and x equals -3. Same thing over here. Another difference I notice, this function increases, decreases, and then increases again, whereas this one over here does the opposite and decreases first, then increases, and then decreases again. So these two, because of this negative here out in front, this second graph is a reflection of the first graph that we were given. All right, so now we're actually going to start talking about end behavior specifically. And what I want to do is not just look at the graphs and talk about end behavior for the graph, but I also want to talk about what's happening with our equation. So I'm going to do 2 things. One thing I'm going to do is talk about our leading coefficient. Another thing I'm going to do is describe the end behavior. And for right now, I'm just going to use words like up or down for the left and the right side of the graph. So here for this first one, since I have x times x, I know my leading coefficient would be x squared. And when we're talking about end behavior, what we mean is where is this graph headed? If there were arrows specifically drawn on the ends, where are we going towards? What's going on? So in this case, the left is going up and the right is also going up. So we would know that that means we're approaching infinity on the left and infinity on the right. And remember, since I'm talking about going up in this direction, I'm talking about my y values here. So here on my second graph, I have x times x times x times x. So that would be x to the fourth. If I put arrows on the end here, so now this had two x-intercepts, my first one. My second one has four x-intercepts, and still both of my arrows are going up on the left and up on the right, which tells me that I'm headed to y values of infinity in both cases. This last one, if I look at the equation, I have 1, 2, 3, 4, 5, 6 x's. So this tells me my leading coefficient is going to be x to the 6th. And again, when I look at where these arrows at the end of my graph are heading, I have up on the left with y values heading towards positive infinity, and up on the right with y values heading towards positive infinity. So if we think about what's happening, why this might be happening, what some things we see with our leading coefficients that they might have in common. Well, I have dropped my extra color. I have squared to the fourth and to the sixth. Hopefully a little red flag is going off in your head because all of those are very specific numbers. They're all even. Another thing I notice is both of these are heading in the same direction. So let's take those ideas and see if we could talk about what's happening on the left and the right. Now, I want you to try these first and then go back and check in Desmos. So I have 1, 2, 3, 4 x's that are being multiplied together. So my leading coefficient is going to be x to the fourth. And there's no negative sign out here, so I know there's no reflection. So my arrows on the left and on the right are both going to be going up. So in both cases, my y values are going to go to positive infinity. We're going to work in a minute on writing this more concretely, but right now we're just going to get a general idea. Here, yes, I have a coefficient of 1/2, but that's going to either stretch my graph vertically or stretch my graph horizontally. That's not going to change what direction my arrows are heading. So I have x. Ultimately, my leading coefficient here is going to be x squared. Since my coefficient out front, this 1/2, is positive, This is another time where, since my coefficient is positive, oh, excuse me, I forgot the 1/2. Sorry. So this is another one where my y values are going to go to infinity. All right, let's think leading coefficient here. I have 1, 2, 3, 4 x's, because remember this means there's 2 x minus 2's. So I have x to the 4th, but I also have to multiply that by -2. So my leading coefficient is now negative x to the 4th. So it's sort of similar to this first one we have, where we were going up and up. But we know when we have a negative leading coefficient that ultimately it's going to reflect my graph. So now my y values are actually going to head to negative infinity and not positive. So now checking out over here, I have 2x plus 2's, so that gives me x squared. This would give me x to the 3rd, x to the 4th. So this is going to be negative 1/2 x to the 4th. Similar that we just talked about over here. Even though I have a 1/2, that is my horizontal stretch. I'm making my graph wider, but it's reflected from this original idea that we had with x to the 4th. So this is going to be down and down, and my y values are heading to negative infinity. All right, let's try these. So I have a linear function. I have x times x gives me x squared times x again gives me x cubed. And now I have, oh, a frozen screen. On this last one, I have 2x times x, but really this is 2 x's. So I have 2x times x squared, giving me x cubed, times 1 more giving me x to the 4th, times 1 more giving me x to the 5th. And remembering I do have a 2 there, so we'll keep it just to remember. Now, really, this is 2x to the 1st, technically speaking. So now, just looking at my exponents to start, these are all odd. Let's see how that changes things. One thing you should notice right off the bat is our arrows are actually going in opposite directions. So I have positive leading coefficients with odd exponents, and my arrows are going in 2 different directions. The left is going down and the right is going up. Same thing here. Left is down, right is, oops, up. I was going to write right instead of up. Same thing. Left is down and right is up. Now, if I reflected this, thinking back to our first example, if I had a negative slope, the left would be up and the right would be down. Same thing here. If I reflect this, this arrow is going to come up to the top. So the left would be going up and the right would be going down. So that's the difference between the odd and the even exponents. So if the degree is even, we will see both sides go in the same direction. So we'll either have up, up, or down, down. If the degree is odd, then the end behavior is opposite. So I'm either going to have down. Ooh, let me actually make these arrows look like arrows. Wouldn't that be nice? I'll either have down, up, or up, down. So if my leading coefficient for A is positive, now I'm just going to talk about the right side where my x values are going towards positive infinity. If it's even or odd, that's going to help me figure out the left side, because the positive and negative is going to help us figure out the right side. So if my leading coefficient is positive, regardless of whether it was odd or even, the right side is going up and the right side is going up. So if A is positive, the right side goes to positive infinity, which means up. Vice versa, if A is negative, remember that gets reflected. So the right side, goes to negative infinity, which is down. All right, let's test this out. I have two functions now, and we are going to determine, based on the value of the leading coefficient and the degree of the equation, we are going to determine what's happening with the end behavior. So starting with f of x, and I'm going to actually do this in a different color. F of x has a negative a value and an odd degree because of this term right here. So A is negative. That means my right side is going down. And since it's an odd degree number, it's cubic. That means the ends of my graph are going in opposite directions. So the left side is going to go up. So there's a lot of different ways that people write end behavior statements. We are going to write this in more of a sentence style. So we're going to make a statement for the left and a statement for the right. So talking about the left side of my graph, that's where all of my x values are negative. So I would say as x goes to negative infinity, remember that's the left side, f of x, meaning my output values, goes to positive infinity. So that is my left-hand side, and I'm just putting that L there so you remember that's the left. And then for the right, let me put a R so we don't forget. The right is where my x values are positive. So as x goes to positive infinity, f of x goes to negative infinity because it's going down. So pause the video. I want you to try g of x without me, and then hit play again and see how you did. So my leading coefficient, I have 2x minus 2, so that's going to be x squared, times this is going to give me x to the third, times that's going to give me x to the fourth. So I have an odd degree. And my a value is positive. So that means my right side goes up, and they're going to go in the same direction. So we're going to do left and right sides again. So the left side is always as x goes to negative infinity. And the right is always as x goes to positive infinity. Now in this case, because it's an odd degree, they're going to go the same way. So this is going to say f of x goes to positive infinity because it's going up. And f of x is going to positive infinity. So that's talking about end behavior.